Yes, hey, Manik, or Manik. How to pronounce it correctly?
Yes, Manik.
Manik. Welcome to Airhacks FM. And the most important question of all is, what was your first computer?
Oh, most important question of all.
Yeah.
It was a BBC Micro. I don't know if you remember
BBC Micro
those.
is a popular one among my guests.
Yes. Once upon a time, I remember writing effectively a Trojan horse for a BBC Micro. This was while we were still in school. It was great. I trolled all the other kids in school with it.
Aha. So you got BBC Micro to write Trojan horses, right?
Yep. It was loads of fun.
Was
BBC
it
Basic?
Basic? Okay. Was it you wanted to become software engineer or write code from the beginning, or you wanted to play games first?
A combination of the two things, actually.
Okay.
I always liked taking things apart and putting them together again. And, I did that with my parents' VCR and they hated it, but, because sometimes I couldn't put it back together again. But it was the same with software as well. So
but how often you disassembled your VCR?
I'm sorry?
How often you disassembled your VCR?
Too often, far too often.
Too often? Okay, I thought once is enough, because you know how it looks inside. And, okay, but it was a continuous disassembly.
That's right. A continuous disassembly. And with software, it was the same thing. I mean, we liked playing games as kids. And back in the day, a lot of the games were password protected. They were copy protected. And we had to find ways to get around that. And I grew up in Sri Lanka where, we couldn't really afford to buy those games. So we'd end up trying to decompile them and try and figure out how to get past the password protection and things like that.
So you got your BBC Micro. So, and the first thing you did, you started to write code or play a game?
Yeah.
Oh, really?
Write code. Yeah. I was just learning how to talk to it.
Okay. And it worked? No.
Yeah.
Okay.
I mean, it's just basic. It's nothing too fancy.
Yeah, but sure. But no. If you get a computer as a kid, and maybe if you turn it on, there's just, I think, as a blinking rectangle, right, on the BBC.
That's right.
Yeah. And how to know what to write? I mean, you prepared already? So you've wrote.
Yeah. No, so we had BBC Micros at school. So
okay, this is easier.
That
Okay,
helped us with it initially, just to kind of get used to it, and then after that, we took it and ran with it in different directions.
Okay. So
someone to basically show us the very basics of it. How to log on and how to do a few basic things, and after that, let your creativity flow.
Mm-hmm. Yeah, okay, but what was then your goal? So I think your first thing was Hello Manik, right? Is your first program?
Yeah. It was just put your name in a loop 20 times. Or
yeah,
whatever.
Exactly.
And then after a while, it was, okay, let's actually try and mimic the C prompt and then hijack people's commands and do other things with it that they're not expecting.
This was your Trojan horse. So it was the first more complex software on BBC Micro?
Yeah, that's right.
Okay.
But we never did anything too complex. We very quickly moved on to PCs after that. And
okay.
Yeah.
So what happened on the PC? So what was your first programming language on the PC, or your first program, or whatever?
Also basic. It was also basic initially, and then after a while we moved on to Pascal, Turbo Pascal.
Okay, which basic? Because there was GW basic, I remember. There was several flavors of basic. Because on the BBC Micro ZX Spectrum C64, the basic was the operating system basically, and on PC is no more the case. So which kind of basic you used?
Yeah, it was GW Basic on PC, and then Turbo Pascal after that, and C++.
And why you switched to Turbo Pascal? It was I don't know. What was the reason?
I was just trying different things. I was just curious, It's there's more than one way to write programs, and it's I just wanted to learn what the bits I didn't know. So yeah.
Yeah, still, but you had friends or magazines, or TV. So how you got the idea?
Yeah, just through friends and word of mouth. If someone would do something clever with something and they'd share it around and say, "Oh, okay, cool, that looks interesting. Let me learn about that," and so on and so forth. And by the time we got to C++ at that point, there was a lot of literature on it, so I could buy a book. And
Okay, got it. Okay, pretty cool. So, what happens then? So, Turbo Pascal. So, what do you implemented? Something on remarkable, noteworthy.
Nothing too remarkable. It's some toys, a few games, a few
a few games is already remarkable.
Yeah, but nothing too complex. It wasn't multiplayer 3D or anything like that.
No. I mean, this is Mission Impossible, but writing a game is, you have some math, some events. So it's just not trivial.
Yeah, like Space Invaders type things, and
Hey, cool.
very simple, relatively simple games. Yeah.
Okay. And
C++, by the time I was doing C++, I was already at that point in university. And for university, I ended up doing computer science as well. And what I did for my final year project was to try and implement a neural network. I picked something very ambitious, and I built that in C++. But yeah.
For OpenAI, was it, right? And ChatGPT came out. Nothing too complicated. ChatGPT, okay. This was like the combination of Trojan horse and your Space Invaders, and ChatGPT came out, right?
That's right. That's the result.
Yeah, that was the result. Okay, cool. And so what about neural networks? Because it's interesting. So you were fascinated by that, and what was the assignment actually?
Yeah, so I was always fascinated in AI, like even from the early days. It's not what AI is today, of course. Back then it was more expert systems, it was rule-based systems, and we had various modules on each of those. So, we ended up building an expert system at one point, ended up building a rules engine, just rudimentary stuff, just to understand the theoretical concepts more than to produce a world-changing piece of software. That wasn't the point. The point was just to learn the concepts. And the best way to learn things, as you're well aware, is to do them, is to try and build them. So, and that was what I was doing with neural networks as well. It wasn't to try and build the best neural network in the world. It was just to understand the concepts.
But was it OCR, I guess, right? No,
it wasn't OCR. Essentially, what my specific project was to try, and it was kind of interesting. I was trying to mimic the learning process of a biological animal, of a bat in this case, of a fruit bat. So I read a paper on, the neural processes and things like that, and try and mimic that in a machine and see if I can teach it to learn in the same ways and stuff.
So you were the Batman back then?
I was the Batman. I was the proto-Batman, the creator of Batman.
And how you tested that, or how to know that it works? I mean...
Yeah, so we ended up creating a bit of an arena, like a game, like a board for it to play in, and you could provide like positive and negative stimuli, like fruits and food and things like that, and things that will hurt it and all that, and see if it figures out how to move across the board on its own. And
it worked?
Yeah. The rules are very simple. It's very rudimentary. It's like you can only move left, right, up and down. That's it. 4 directions. And then, see if it learns over time, how it figures out how not to go close to certain things and what you can go close to and what you want.
But it's already amazing. I mean, it's almost like a Tamagotchi back then, right?
Yeah, that's right. And the interface actually looked a little bit like a Tamagotchi. It was the graphics really shitty, like a TUI, sort of, very basic, but yeah.
Was it a lot of to do? I mean, it was like, in C++, you used an external libraries, you wrote everything from scratch, and how hard was it?
Yeah, not so hard, actually. I mean, well, the bit that I was learning was interesting. So the actual neural network was all from scratch. But like the visual representation and stuff, I reused a lot of libraries, for example, to plot something on a graph and make something move and things like that.
What I remember, I also had some neural network stuff at school, and it was basic matrix multiplication with floats. This is what I remember, and this was actually easier than anticipated back then. So everything around was harder, but this was actually kind of magic, because how was it? You knew the result, right? And you have to try out, what's what's inside the matrix. This was actually the idea, right?
Right.
Yeah. And how big were your matrix? Do you remember?
I think it was like a 64 by 64. Sorry, 64 square grid, so 8 by 8.
Okay. So we did it by hand.
We ended up with bigger and bigger, but we didn't do anything too big. No.
Okay, but still big, 64 by 64.
Sized, so,
okay.
Sort of world.
Cool. So I'm already curious. What's the next project? This is my is a steep trajectory, from Trojan or BBC Micro to bats, Tamagotchis, and couple of.
And that was actually not an academic one. Because I was also trying to pay my way through university, and I would pick up a little bits of work along the side outside. And this was back in the late 90s. It was 97 I'm talking about. And internet commerce was just starting to become really popular. And there were a lot of companies selling very expensive packages to process credit cards and build you a shopping cart online. Things like Intershop back in the day, which is like the license for Intershop was $100,000 per install. So, and this was back
interesting part, Manik. Intershop was a German company from Vienna.
Yes, that's right. It's a German company. That's right.
And
And
1997, one of my first projects was to compete with Intershop.
right. So that's what I was doing as well, actually.
Hey, cool. So
I was
we're
basically building
competitors,
my own,
actually,
like,
the entire
very,
time.
very bare bones, very sort of bunch of PHP scripts, really, to kind of give you like a web shop. And I was writing this code for a bunch of companies that wanted it, and I was making a couple $100 a month doing that, which was great as a student, right? To have a little bit of pocket money, a bit of beer money, and so that was the next project, if you will. What was interesting is soon after that, I actually graduated in Singapore.
So you implemented an e-commerce solution with PHP?
Yeah, it's very custom to each company that needed it. So it wasn't like a general scalable thing. It wasn't like Intershop in that way. But yes. But what happened then was I actually graduated in 98. And 98 in Singapore, there was a massive financial crisis in Southeast Asia, which meant it was really hard to get a job. So trying to find a job.
So you lived in Singapore?
I went to university in Singapore.
Okay.
Trying to find a job out there, it's just really, really hard. It wasn't happening. My visa ran out, so I couldn't stay there anymore. I had to go back to Sri Lanka. So I went back to Sri Lanka. It's like, well, what do I do now? It's like looking at a bunch of banks and things. Do I get a job here? Do I get a job there? I met a friend of mine from London who was visiting Sri Lanka at the time. He's Sri Lankan, but no, he lived in London. He worked for a big ERP firm in London. He was ready to quit his job. He was like, I hate my job. I don't want to do this anymore. I've saved a bunch of money. I want to go start a company. And I'm not entirely sure what I want to do, but I want to start a tech company. There's a big boom happening right now. So I got to know the guy. He was a friend of a friend. Met for beers at a bar, and he was talking about his background. And I was telling about mine. I was like, just graduated from Singapore. Here's all the stuff I was doing. And he says, a great idea. What if we take those PHP scripts and can we actually scale that? Can we make that like a multi-tenant sort of system? And I was like, we can try. I've never tried it before. We're sure we can give it a go. And that became my first startup, really. So we started building that together. I decided I'm not going to get another job. I'm just going to work with this guy. He had some money saved up so we could bootstrap a company.
What was the name of the startup?
We ended up hiring like 10 people in Sri Lanka, which was quite cheap. I stayed in Sri Lanka. He moved back to the UK so he could find customers in the UK, in London, to sell to. And that became our business for about 3 years. And that was great. We scaled out running those PHP scripts. We ended up buying a bunch of hardware, running a bunch of machines. I learned a lot of MySQL at the time, learned a lot of Linux at the time, just hacking everything together to try and, it predates containers and everything. There's no such thing at the time. Very janky forms of multiprocessor, multi-tenancy that we were doing. But it worked, and we were able to sell this stuff, and we were able to, do a dynamic skinning and everything else, so the look and feel would change based on who you were and what you needed. And we ended up with a bunch of customers in the UK, which was great. They were paying us enough money to keep the lights on, but we weren't trying to make a lot of money from them. What we did do is we negotiated saying, we want stock in your company. We'll give you like a startup rate, so you don't have to pay us a lot of money, but we want a couple of % stock in your company. We ended up with like 10, 15 companies that we were running this stuff for, and we had lots of stock in all their companies. And then guess what happened?
9/11.
In 2000, a big .com crash came along, and I shit you not, they all died. Not one of those companies survived. We were thinking if just one survives, we'll be fine. Not even one survived. So, well, our company died as well at the same time.
Yeah, otherwise you would be now, multi-billionaire, right?
Yes. Well, I mean, one of our customers actually is a small bookshop in London, and they were they just heard of Amazon. And I said, who are these guys, Amazon? They're selling books online to compete with us. Well, we're going to do the same thing. Can you guys help us do that? I know you've built shopping carts and checkout software. Can you help us sell books online? I was like, I think we can. We'll have a deal. And it's like, we'll be your technology providers. We'll run everything for you. We'll operate everything for you. We want 5% of your business. And they said, yeah, sure, it's a deal. Now, sadly, they didn't turn into Amazon, but there's a chance they might have.
Really sadly, yeah. Okay. What was the name of the startup?
The startup was called Silk Road. Silk Road Software. Nothing to do with the current Silk Road.
Okay.
It's, unfortunately, a bad name, but yeah.
Yeah. Interesting. Didn't knew that. And okay, then 9/11 happened, and everything was PHP based, right? So far.
Yes, that's right.
And
we started to venture into Java a little bit. We started to venture into Java a little bit for a few things. One of our customers at the time was a Java shop that ran on Solaris and everything. And they were like, no, we love what you're doing. This is great, but we're not running PHP and this stuff. We want it to be rewritten into Java. So I ended up rewriting everything, reported everything. It was for this one particular customer, but then we ended up learning a lot of Java in the processing. Actually, this is really a good idea. This actually seems to be working really well. I think this is a more scalable system and things like that.
Okay.
And that's when I got my first job in London, actually. As we shut down the company, one of our customers who was still London-based, we'd already shut the company down. We'd let go of the team and everything else. But we still had a little bit of work that we were contracted to do with one of our customers. So I flew over to London to finish that work up myself. I was on site with them. We did that stuff. And while I was in London, I just looked for another job and I got one. So I was working for a small consultancy in London. And the first project they had was, it was effectively a 3-year-long project, but it was with Virgin Atlantic, the airline, building their online check-in systems and airport kiosks and everything else. One of the first few airlines ever to do that. This was in 2001, right? And the consultancy that I worked for, that they hired me, they were a Microsoft shop. They did everything on Windows. They did everything on with C# and stuff that predated C# as well. And the contract they had with Virgin Atlantic, of course, Virgin Atlantic were a WebLogic shop. Everything's a WebLogic and Oracle and Solaris. And they had no idea how to do any of this. That's why I got a job. It's like, oh, you know Unix, you know Java. Do you want a job? It's like, yep, let's do it.
Super cool. You mentioned earlier that you had to buy hardware for your startup. Was it Sun machines? Were the Sun machines or what you bought?
Yeah, they were Sun machines.
Okay, cool. No, which ones back then?
Can't remember now, I'll be honest with you.
Uh-huh. So, I think the small enterprise, the not boxes, they look like a cubicle, like a cubic stuff,
That's right. They were blocks, yeah.
Yeah, like exactly. This is like a monolith block, exactly.
Yeah.
Yeah, interesting stuff you did with. I was not aware at all that you are actually a businessman, not a software developer, right?
A little bit.
A little bit.
Then of course, I know you from my Red Hat days, right? And that journey happened very soon after, because at one point I remember we had built this thing for Virgin Atlantic. It was all, like I said, on Solaris, on WebLogic, on Oracle. And I sort of took it upon myself to say, I bet we can run this on an open source stack. We don't need to be doing all this stuff on proprietary systems. So myself and a couple of my teammates, we decided to take a week off and just try and port everything. And we did. There was a very early version of JBoss, an early version of MySQL running on Linux. And we did it. And we didn't have to change too much in the actual Virgin Atlantic system. And we took it to the Virgin Atlantic CTO and demoed it to him. And said, look at this, right? All the stuff you're paying Oracle and Sun and WebLogic, you don't need to do that anymore. Check this out, entirely open source stack. Do you know what he did?
Said, no, I don't.
He took that demo and then negotiated for a discount with Oracle.
Okay. This is, yeah.
That's not what I was expecting. I was like, this is going to be great. We're going to port everything to open source and it's going to be wonderful. I'm a hippie at heart, right? And it's like, nope, that's not what happened. Oh, well.
What I expected, it would say, no, thank you. We have to pay the license fees, in order to have, I don't know, insurance or whatever, how it's called, indemnification of, license stuff back then was big and stuff like that. But this happened to me several times back then. So large companies hired me, multi-product Java E, and this was a great success story. I forgot about that actually, is because they could negotiate a better license fees, because we could show that our system runs on any runtime, and they were not depending on one. So actually, this was a huge selling point for Java E, which I completely forgot. But now we are back with you.
That's right. This was back in 2004. It's like even back then it was used as a negotiating tactic. But for me personally, that's what got me into JBoss. That's when I really started to understand the JBoss stack really well. And then in my next project with the same consultancy, it was for the Financial Times, and we were building out their web stack.
Wow, there's big projects actually. This is crazy what you did.
Yeah, they were really cool projects. They were cool things. And this was running on like a cluster of Apache servers, and there's a lot of caching on the front end, cache web content and things like that. And I was using JGroups at the time for a lot of that stuff, because this company was much more, the Financial Times was much more open source friendly, running on Apache and everything else, running on Tomcat and all of that. So I introduced J groups in there, and we started to distribute a lot of the articles and the content across their cluster of 20 or 30 machines. And of course, there were things that were broken in J groups, so I started fixing them and contributing it upstream and everything else. And that's when I met the J groups folks and the rest of the JBoss folks and everything. And at some point, they said, "You know what? You're contributing all this stuff. Why don't you come on over and meet us? We want to say hello." So, went over to Switzerland to meet them, and before they knew it, they had a job offer on the table saying, "Why don't you come and join us full time?" And the rest, as they say, is history. I mean, that's JBoss thing got acquired by Red Hat. And
what you started with PHP, and then you rewrote that to Java or in Java.
That's right.
What was your reaction or opinion of Java back then? Because I think PHP was it's simple. Java is a little bit more complicated, I would say. So you like Java immediately or not?
I really liked it. I liked it for a number of reasons. I love the fact that I could look at bytecode and can make sense out of it. I can reverse engineer the bytecode and make sense out of it. The fact I loved the ecosystem of Java, that there were so many libraries. PHP had a lot as well, but Java felt like, wow, this is a lot, and I can go as deep as I want in any one of them. And that felt fascinating.
Interesting. What's also interesting, I had a podcast episode with Belaban.
Right.
And Belaban is the J Groups guy, actually.
That's right. He's the guy who hired me. He's one of the guys who reached out saying, "Come on over to Switzerland. I really want to meet you. You seem really interesting. I like your work."
And he liked your work because you found the bugs, right? That was the...
That's right, but I think it was just the engagement. I mean, the way we were working together online, the way we were, throwing things back and forth and iterating on things, iterating on ideas and stuff.
Is this how Infinispan happened?
Infinispan happened a little bit later. So when I joined JBoss, they just started a new project called JBoss Cache, and JBoss Cache is built on top of J Groups, and it was a part of the app server to distribute session state. Now, JBoss Cache was one of the things that I worked on before I joined JBoss. I was contributing a lot to it. I was trying to fix it. I was using it at the Financial Times for their systems. So that quickly became my baby. So when I joined JBoss, I was like, okay, you're in charge of JBoss Cache. That's your project. You oversee it. So I was doing that for a while, and that was great. We took it really far. But at some point, we found that people were trying to use it as a key value store. People were pulling it. When we were downloading JBoss, the app server, pulling out JBoss Cache, changing the interface to a key value store, and using it as a key value store. I was like, there's clearly the market wants something else. The community wants something else. And we're building something that we think is clever and useful for the app server, but there's another thing that people want as well, and that was Infinispan. That's how the Infinispan grew.
And this is when we met the first time.
That's right.
You remember that?
I do, yes. As a part of, it was the Java 1 year, I believe.
No, this was a conference in Poland. I forgot the name.
Oh, that's right. It wasn't Java 1. It was
Nights or whatever. So there was a dinner with Nights. It was in Krakow. This is a Polish city. And I delivered a talk about, I guess, enterprise, maybe with JBoss even. And you approached me and you asked me whether I use JBoss Cache as a tree or a key value store. And we had a chat. And what I tried to explain to you that a tree is a bad idea because of locking. And what we actually need is a hash map-like distributed cache. And this is really hard with JBoss Cache with the tree cache, because back then there were like concurrency modes, and you can choose between consistency or more or less pessimistic and optimistic locking. The problem is, and pessimistic locking in a tree is hard because a tree can be quite deep, and optimistic locking is also not easy because what is consistent and inconsistent in a tree. So we had a chat about that. This is how I remember. This was like a late night, and we had chat about JBoss caches and KV stores. And back then it was JBoss Cache, and I used the JBoss Caching project for simple things. And you told me about Infinispan actually back then.
Well, that's a great memory actually that you have. But that's exactly what I mean by lots. And you weren't the only one. There were several other people in the community as well that were saying, well, this tree structure, this tree cache isn't working for us, and we're trying to make it behave like something else. Now, the tree cache worked really well for what we used it for within the JBoss app server, which is handling session state. But it wasn't designed to be a general purpose thing for everyone to use, where people were just hacking around and pulling it out and trying to use it. So,
were there any other killer use cases for the tree cache? Because actually, interesting concept. There are not a lots of caches based on trees, right?
Yeah, there's not a lot. We had something called a Pojo cache once upon a time. We were experimenting with that, where it would decompose entire object graphs and try and put that into a tree structure. And that found some success a little bit, but it wasn't.
Almost like a Hibernate in memory.
A little bit like that, yes. A little bit like that. Yeah.
Okay.
But, I mean, the hash map sort of structure saw much more utility. It was, as you said, much easier to implement, much more flexible, much more powerful in many ways. Like, you could end up doing lots of eventual consistency modes. You could do a lot of different forms of locking and hashing and distributing the structure and things like that. So
and you could still, store a tree-like structure as a value, if you like, right? Because you could still have your
that's right.
Java objects or JSON, whatever. So it would just work.
That's right. And also we had like some really good popular use cases in the marketplace that showed that was a useful abstraction. The biggest one was probably what was it called now? There are a couple of commercial products that were doing
Redis.
very well. Redis today, yes, but back then there were a few more, and the name escapes me now, but they were very popular, especially in the financial services space and things like that. So we were like, well, cool. People are paying lots of money for these products that basically does the same thing as
Terracotta.
Terracotta, that's the one.
Terracotta was a bit different, but Terracotta was one. And then from Oracle, the cache, which was bought by Oracle from an external company, and
that was even bigger than Terracotta, if I remember right.
The name was cool of the Oracle cache. I have to search for it because I also had.
It'll come to me. I mean, it's a complete blast from the past for me. All this stuff, yes.
Yeah, which is good actually, because the principles back then were not that bad. So it is still valuable to know what happened back then, because you can absolutely reapply the patterns and ideas and experience to present technologies. There's actually
Tango Sol coherence. That's what.
Coherence. Exactly.
Just occurred to me. So we really had there was some proof there that people were finding success with that sort of data structure and that sort of access pattern.
Mm-hmm. And I had an interview with Cameron Purdy, which is actually a really funny guy, and he implemented the Tango Sol coherence and sold to Oracle. And now he implements an own cloud language.
That's right. Yeah.
Super cool. Okay, and it means JBoss cache was 3, and the refactoring to a hash map became InfiniSpan, right?
Yes, that's right. It was a complete rewrite. At that point. We were taking all the lessons learned from JBoss cache and completely rethinking everything from the ground up.
What were the lessons learned? So what were, the major parts?
A lot, actually. For one thing, don't use the tree structure. But another thing was the way there was a lot of very clever abstractions in the implementation detail of JBoss cache that were very cool and made it almost infinitely flexible. But we paid a heavy performance penalty for it. So it was very heavily reflection-based and lots of interceptors and things like that. And we're like, there are better ways to do this. We don't need to be infinitely flexible. There are only really a few things anyone's ever going to do with this. So we don't need to, use a lot of reflection magic to figure out things on the fly. And as a result, performance just went up through the roof compared to JBoss cache. And the other one was serialization. JBoss cache, if I recall right, just relied on Java serialization and pros and cons there. And we decided we can probably do better than that. So we ended up firstly making the serialization mechanism pluggable in InfiniSpan, so you can bring your own. And then we had a couple of very, very sensible defaults that just took the raw essence of what you're trying to store in there. So again, much smaller in terms of memory footprint, much faster, things like that. But also it meant that it was flexible. And I think today most people use InfiniSpan using protocol buffers, for example, because once protocol buffers became a thing and so it took off, it's like, well, that's the standard way of doing any sort of serialization now. Let's just do that. And because it was extensible and it was easy to plug it in, that just worked out of the box.
There was a hot rod protocol, I remember, right? In
That's right. That was not a serialization protocol. That was a peer-to-peer protocol.
And
So
what you could do is that
it was a client server protocol. It was so that like if you had a cluster of InfiniSpan nodes running somewhere and you had a remote client somewhere that could talk to that.
Mm-hmm. Because the cool story was what it could do is it was not hot rod. It was like on startup, you can pre-fill the cache. So then you can use InfiniSpan as a almost persistent storage, because if you have enough node, which are up, then everything was persistent, right?
That's right. Yeah, persistence in memory, persistence via replication rather than persistence via disk was the idea.
But you can still have persistence via disk, because they were like listeners, I remember. So what you could do is on every change you can persist to disk on one node, and it became persistent. Okay, so it's interesting, because what you said is that convention over configuration, right? So if you know what they are doing, opinionated software, you can remove lots of flexibility, or lots of configuration becomes faster and simpler to use.
Yeah. Absolutely.
But the first iteration was necessary, I guess, because you knew exactly what's needed and where this flexibility is not needed. And then you could,
100%.
Yeah.
I mean, I don't think, like, if we didn't have JBoss cache as a starting point, we'd be making those mistakes for the first time
exactly.
in InfiniSpan. And then it'd be InfiniSpan 2.0 that actually became more useful.
Mm-hmm. Like that. But what changed from the approaches, I would say, is back then we tried to be flexible, not to to make a mistake which is hard to fix in the future. And how I'm thinking today, I write simple code, and if the code is simple, you can correct it in future very easily. So so this exactly the opposite what I did 20 years ago. So right now I would say, okay, I don't care about configuration, nothing. If I just write simple Java code, you can still change it, no problem, right? And back then it was unthinkable. So everything has to be thought out, and we had hooks, and everything was flexible, and often even configurable at runtime, right?
Absolutely. I mean, the world certainly is different from when it was back then. To what you're talking about. But if you fast forward to today, even things are like, I mean, as you're well aware with AI sort of generated code, it's even more extreme. Like all code can be thrown away at this point and just regenerate on the fly as you need it.
What happened with InfiniSpan? So how long? This is what I lost you somehow. So when you stopped working on InfiniSpan, what was your next journey?
Yeah, so InfiniSpan today is still a popular product, I believe. Red Hat still sells it, and I mean they have a commercial version of it, and they're still monetizing it. It's a pretty important revenue driver for them. But my journey sort of parted ways with Red Hat in 2013. Nothing bad. I mean, we had a great time. I was like, I was still leading InfiniSpan and the internal product and a whole bunch of other things, and a whole bunch of integrations with Hibernate and stuff. So it was lots of fun. But I was at Red Hat for 8 years at that point, and I think I was ready for a new challenge, just something different, I heard of an opportunity at Square, which was at the time a small payment startup out of San Francisco. I believe we have a mutual friend, our dear friend called Bob Lee, who's no more, unfortunately. So Bob Lee was then the CTO at Square, and he reached out to me and said, well, I really should join. We're onto something here. It's a really cool company, and we're doing some really cool things. And his pitch,
and it was also called Crazy Bob Lee. Also, right?
So some people, that is Crazy Bob.
Crazy Bob, and he actually implemented a CDI. He started Juice.
Right. That's right. He was involved in Juice, and a lot of Android as well. A lot of the Android APIs came from him. So I knew him through the Java One circuit and things like we go to conferences together and lots of public speaking together. And he knew I was into clustering and scalability and high availability and high performance computing and things like that. And his pitch to me was Square at the time was running as a giant Ruby on Rails monolith. And he was saying, we've just closed a deal with Starbucks, and we're going to be processing all of Starbucks payments all over America. So we're now in the big league. Now this is no more a demo product running for a few small things. This is now big. But the problem is now we have serious SLAs for uptime, and that Ruby on Rails monolith doesn't have great uptime. What are we going to do about it? So that was his pitch to me, saying, come and help us redesign and rebuild our payment stack in Java, multi-DC, things like that. So make it really highly available and architect all of that with us. And I was like, that actually sounds kind of cool. So I joined them. I joined Square for a while. worked on that payment stack for several years.
And you rewrote it in Java?
Yeah, that the work had already started by the time I had joined. So some folks had already started on that work. So I joined that group, that initiative. And they were all like, decomposed into microservices at the time, moving away from a monolith. So we had a whole bunch of different services spin up for talking to credit card companies, moving money between bank accounts, doing chargebacks, doing refunds, doing reversals, all of that stuff. Whole host of microservices to do all that. But a lot of it was designing the infrastructure around it. Like, what does deployment look like? What's our deployment process look like? How do we do red-green deployments across data centers? How do you flip traffic from one to the other? So there's a lot of really interesting architecture work happening there to build all that out. So I did that for a while. And then at some point I was involved in a project to shut down the old Rails monolith, which still existed. So I led that initiative, which was fascinating. Because while most of the hard work of the payments had been moved out of that Rails monolith, it still had to write back to the payments table in the monolith, because a lot of our back-end systems still use that monolith. So that had to be kept coherent, consistent. But that, of course, couldn't scale anymore. We were hitting limits. We literally couldn't buy a bigger database for that machine. So it's like we're hitting a wall. The business is going to have to stop taking payments at some point if we keep going down this path. So you can't do that. But it also couldn't take any downtime, because this is a the hot path, this system. So we ended up building a cluster of, systems to mimic that API endpoint, move traffic over, gradually be able to move back and forth between them, double writes, all this stuff. Really fun project, but, really changing the engine while the plane's in the air. That's what it felt like. So.
And was the Ruby system well tested?
I'm sorry?
Was it well tested, unit tested, the Ruby system?
I don't know what to say about that.
Yeah.
No, basically.
Because why I'm asking, what I remember, it was like, 2006 to maybe 2010 was tough time for Java. Because all conferences, every project, I was asked, why you are doing still Java? Ruby is way better, Ruby on Rails, and it will just take over the world and Java will die. And I ask why, or the reasoning back then is Ruby is not type safe, but it doesn't matter, because you can very easily write tests, and there are lots of unit tests, and therefore this is like the safety net. I remember the argumentation. And Java, the problem is it is strictly typed, which is not productive, and it's way harder to write tests, and therefore Ruby is more maintainable and productive. And I couldn't understand it back then. And I say, maybe, we have no chance with Java and Ruby is so good. And then after a while, I started to ask, and it turned out that actually whatever was said about Ruby on Rails in most projects was not true at all. This is what I'm asking, It was just a huge monolith. And after a few years, we got contract back to migrate back from Ruby to Java. What happens to me right now in some clients ask me, to help to rewrite Node.js back to Quarkus, for instance, which I also find fascinating. Is actually the same thing, right?
That's right. That's absolutely it. Especially with something as complicated as that monolith, there was not adequate tests. Or if the tests were there, they were really brittle and just tied to the code, like a mirror image of the code, which is actually meaningless, and makes it really hard to change anything. So it was definitely hard. We did our own testing outside of it. Like, we wrote our own separate service just to look at the specific APIs we were moving, and just to test those as a black box from external viewpoints, and then run that on both systems and things like that. So we had to build a lot of our own infrastructure to help with that migration, but that's what we ended up doing. And then,
after your migration, Square became a pure Java shop?
No, we're still not a pure Java shop. We've always been a bit of a polyglot sort of environment. Okay. There's still a bit of Ruby out there. There's some brand new Ruby services still being written out there, but they're being written as microservices. And that's a very different picture from the monolith that we had. The microservices are far more manageable and tractable. You can test it easier. You can deal with downtime easier. You can do a lot more with that than you can with that really large, heavy monolith. We also have a lot of Go services. We've got a bunch of Python services. In fact, Java's sort of on the way out at the moment, where everything's sort of being Kotlin's becoming the lingua franca of the company right now.
Interesting.
Yeah.
Because for me, I thought, Java 25 and so is so lean and clean that at least in my project, it absolutely dominates. And
I would think so too. But there was this, I mean, like, there's been a lot of push for, I mean, Kotlin seems to have just won everyone's hearts in the company. Everyone just loves writing in Kotlin. Personally, I don't understand it. I'm not a huge Kotlin fan, but it's like our philosophy really is you do what the people want. Whatever makes people most effective at their jobs, do that.
So I will apply as a Ruby developer in your company again. It's like I love Rails or PHP. Are you still working for Square?
I am actually. Well, the company's renamed to Block. We renamed ourselves about 5 years ago. But I'm still at Block. It feels like I've had 3 or 4 different jobs at Block as well. So has moved from being like a staff engineer to being like an eng manager to being a VP of eng to now I'm an IC again, which is great. So kind of like going all over the place.
So what are you doing right now? So what's your role, or what's your?
So as of about so just as prior to this role, I was a VP of eng for Cash App, which is one of our big business units. I was responsible for moving Cash App out of our data centers into AWS, and then I ran the cloud platform. There was about 100 people, everything from databases to event queues to service discovery, our Kubernetes clusters, all of that reported up to me. And at some point I was like, I think I need to get out of management. This is not they're not doing it for me anymore. So I was like, okay, well, I quit. I want to go do something else. And so they convinced me to say, hang on, no, we're actually going to pivot the company to try and become an open source company. And we need someone to be our head of open source. Would you do that? And I was like, you know what? That sounds like a great idea. That would be fantastic.
Yeah, it fits perfectly actually with your past. Yeah. With
my background, with everything. So it works really well. It's been a really fun journey. So we've established an open source programs office. It's a pretty well-developed function now. There's a lot of mentorship of internal open source projects and helping new people contribute, work with the communities. We're doing a lot of inner sourcing as well. So internal non-public code is still shared internally as though it's an open source project. Anyone internally can contribute to it and enhance it and what have you, like an open door policy. And of course, we're doing a lot of traditional open source as well. I mean, some of the most popular Android libraries came from us. I mean, this is another fun fact, like gRPC, so it came from us as well. It was a collaboration between Block and Google, actually me personally and Google, and gave birth to gRPC many years ago. We're currently doing the same thing with a lot of AI work as well.
Then I have to re-invite you back and talk about gRPC just for fun.
Yes, absolutely. I'd love to do that.
Yeah, this would be actually a cool thing. So, because for me, gRPC is nice, but it reminds me of Corba. Absolutely, with IDL, and it is very, very similar. And yeah.
I mean, look, there's lots of echoes, lots of lessons learned from Corba as well that we took on. And there's a reason why people built stuff like that, because you wanted to be able to have a mesh of microservices written in different languages and still being able to talk to each other and doing it in a high performance way. So, that was gRPC. When I started the role as being the head of open source, we had something like 600 open source repos, most of them tiny, most of them just a couple, some of them dead, some of them no one's really watching them anymore, but some of them genuinely impactful, huge things. I was like, but no one talks about them, So a lot of it was a little bit of a PR role to say, look, this is actually what we do in open source. We are significant, and using that to encourage more open source. And that became a powerful flywheel within the company. We've joined a number of foundations. We've joined a number of standards bodies. We're working with lots of partners now on things, which is great. We weren't doing this a year ago. So that's been a really fun sort of ride. And more recently, I've focused a lot on AI as well. So one of our projects that got really popular was something we built called Goose. Goose is a coding agent. Now, this predates Claude Code, by the way. Predates Claude Code, predates Codex, all the popular things that you see out there today. We first launched Goose as an open source project in January 2025, so just over a year ago. But it had been an internal project for a few months prior. 5 people in the corner building out this thing back when state-of-the-art for AI was GitHub Copilot, right? And autocomplete in your IDE, basically. I was like, no, we can do better than this. Or you're copying and pasting with ChatGPT here. You can do better than this, right? So we built this thing called Goose, where it's a command line thing. It runs in your console, and you give it access to your folder, you give it access to a whole bunch of tools, and you just tell it to go and do things, and it does it. It's like, okay, this is a bit janky. It wasn't great, but it was okay. You could see where it was going to go. Lots of people internally started adopting it. It went from 100 people using it to 1,000 people using it to like, holy shit, this is actually going to get really popular. And I said, we should open source this. This is going to be great. So we did. And just before we open sourced it, actually, we were thinking we need to give it like more standard ways to access tools. It's just doing bash shell script stuff at the moment, but I wanted to access my database. I wanted to access my message queue. I wanted to access internal systems like my HR system or Google Drive or GitHub, right? How do you do that, right? And we don't want to customize each interface. So we went back to Anthropic. We worked quite closely with Anthropic at the time, and we still do. And we're like, how can we work on this together? How can we work? What's a better interface? And we ended up co-designing MCP with them. So we became design partners. They were implementing MCP and coming back to us saying, try this, will this work? I say, go try this. No, it doesn't work for all these reasons, take it back. And I go and try another version, come back, does this work? And after a while, MCP was born, right? So we then open sourced Goose. MCP also became open sourced at the same time. I was like, this is great. And the community took it and ran with it. We ended up with 19,000 stars on GitHub in like 2 months. And now it's like 30,000 stars. But, it like exploded. Goose became really popular. People were contributing MCPs and plugins for Goose to talk to Figma and learn design, to talk to your calendar and organize your calendars for you, to respond to your emails for you. All the stuff that like Claude Cowork does today and is really popular. We were doing this a year ago, right? In Goose, with a whole bunch of plugins that the open source community created. So that started to snowball and get really popular. At this point now, Goose is used by 5,000-6,000 people within Block, right? Loads of people are using it, not just engineers. Designers are using it. Our legal team are using it. Our sales teams are using it for all sorts of things. It's like, this is cool. Other companies started using it. Stripe started using it. Databricks started using it. Snowflake started. Loads of other companies using it. This is really cool, right? And then we found that this is fast forward now to about July last year. And we're starting to see some headwinds a little bit on the Goose project. The headwinds really are people like Stripe, for example, saying, this is great, we love this stuff, we have our own fork, but we can't contribute our changes back. Or Red Hat actually said, we want to put this in Fedora and we want to distribute it to our customers, but we can't do it yet. I was like, why? What's going on? And I say, well, the Apache license is great, it's really permissive, I understand that, but you guys still own the trademarks. And we don't know if you're going to now suddenly start charging for it or you suddenly kill the project. And if we've now attached ourselves to it, that's too dangerous. So that's when the talk of moving it to a foundation started coming up.
Agentic AI Foundation.
The Agentic AI Foundation, that's where the story's going, yes. So it's like, you need to go, build a foundation for it somewhere safe. Mm-hmm. The CNCF reached out to me. We were chatting with them, saying, should we go to the CNCF? I was like, maybe, but it's not quite the right fit. We spoke to a bunch of other people. We talked to the Linux Foundation, to the Apache Foundation, so on and so forth. And then I got news that Anthropic are thinking of the same thing with MCP because they had the same headwinds of adoption. They were starting to see that. And they were like, okay, well, we know those guys pretty well. We reached out. We had a chat. We found out that we're very aligned in our thinking, in our mindset. And we're like, tell you what, let's create a foundation together. Rather than a separate one for Goose and a separate one for MCP, if we did one together, it's going to be better for both of us, right? I said, yeah, it sounds like a good idea. Let's do that. And then that started to get momentum. And then OpenAI heard about it and said, shit, can we join? Like, sure, why not? Come on in, what are you going to bring? So they joined the party as well. And it just started to gain momentum.
Yeah, it's crazy. AWS, Cloudflare, Google, Microsoft, Bloomberg, Block, Anthropic, everyone is on Agentic AI.
That's right.
Huge coincidence. What happened is last year in December, I have a few times in a year, I deliver workshops, online workshops. And this one was about, it was like LLM assisted development with Java.
Yeah.
And I like standards, of course, because standards actually were pretty cool because whatever I did 20 years ago is still working right now. So I'm not really interested in proprietary stuff. And the problem, what started to happen were rules, steerings. So every tool had own way to tell LLM, what you would like to do, how you would like to do. But Agents MD is part of the Agentic AI Foundation's Linux Foundation. And in this workshop, I presented actually Goose and showed them that Goose, Agents MD, so it was, a few months ago. And I completely forgot that it was actually by Block. And I had no idea that you are also working for Block. This was like, this is crazy. And recently, one of my clients asked me, but we could use Cloud Code, but Cloud Code can only connect, to a Bedrock or to Anthropic model, and Goose is completely free, so you can use local LLMs, whatever. So, so I show them Goose, and I say, hey, look, you can connect with whatever you like, and it is absolutely open, and they also like it. So this is why I was pleasantly surprised that you know about Goose actually. And you are actually behind the whole initiative, which is crazy. And Goose looks like world. Yeah. And the cool story is if you start with Goose is like pick your model, and this is an entire dashboard of models. You can pick whatever you like, whatever cloud provider you have, local or not local. I would say from this perspective is maybe one of the most flexible tools which you can connect with. But it's visual. It's not in terminal. This is like an app. This is a Mac app in my case. It looks like Cloud Code, not Cloud App, not Cloud Code. This Cloud App is like, it's a Mac native app. Mm-hmm.
Yeah, it's got a command line interface as well. It's got a TUI as well. Mm-hmm. So it can look like Cloud Code itself as well. So it's got both interfaces. We've got a mobile interface as well that's new, and that's going to come.
Okay, so I will have to re-invite you every other week. It looks like, because there are lots of stuff to talk about. But maybe are there any other interesting blog projects? So as cliffhanger. So we had a Goose and stuff like that. Maybe older projects, whatever you have. So now, what are the most popular, most interesting projects?
Yeah, I think our most popular, aside from Goose at this point, would be OKHTTP.
Oh yeah, exactly.
OKHTTP is the default client library in Android. Mm-hmm. It's also used on the server side quite a lot. High performance, and through that you have OKIO, which is a separate IO framework, which again also incredibly popular. Retrofit is another Android library for creating clients out of REST endpoints. We've got a memory leak detector for Android that's open source. It's very popular. Mm-hmm. We've got the rest are mostly smaller libraries and plugins for existing.
But still a lot. HTTP, I knew it. I had also no idea that blocks behind. Interesting. And if someone who is a typical Block customer, is that a developer, is it an enterprise, or
So Block is it's a collection of companies. So when you say who's Block's customer, it's everyone really.
What is the main use case? Main use case, maybe.
Yeah, so the Square business, the main use case is registers and terminals in coffee shops and things like that. So again, the main customer there is anyone who goes to. So our customer is actually a merchant.
Okay,
is anyone who's selling something. Is that side of the commerce equation. Afterpay is one of our businesses as well. So in the case of Afterpay, our customer is a consumer who wants to not pay for everything up front and wants to split their payments. Mm-hmm. Cash App is another one of our businesses. It's basically a neobank in the US. Mm-hmm. Think of Cash App a little bit like Revolut or something like that.
Okay.
It's slightly different, but so very popular in the US. It's got 75 million monthly active users or something, so a huge user base. And in that case, our customer is everyday people who don't want to use a traditional bank.
Yeah, but could you? This is almost like a PayPal as well, where you can have a payment gateway and you can buy book online or whatever.
Yep.
So you can use you via API to sell stuff, right?
You absolutely can do that.
So you're a competitor. You're competing with Stripe and PayPal and stuff like that, right?
That's right. Different parts of the business are competing with them like that. Yeah. Mm-hmm. And I don't know whether you knew, but we also own Tidal, the music streaming service. That's another one of our businesses. And again, the shape of our customer is very different in that case.
Yeah,
it's
sure.
Just everyone listens to music, but actually, Tidal is more geared towards music creators than music consumers. It's more popular with DJs and artists than it is with actual consumers. But yeah.
Okay, so you if you produce music, you can sell it over Tidal.
That's right. and you get a much more fair sort of pay compared to some of the other big streaming services. We also try and disrupt the record label model, where we will extend microloans to artists to say, look, we can see if we're monitoring your work, and we can see how popular you're getting, and we'll give you money to go and create your next album, so you don't have to go to a record label and sell your soul, things like that.
Okay, as a cliffhanger from my perspective, just because you mentioned LLMs and code, and what I found out, actually I'm back from JFocus conference where I had a talk about that yesterday, and what I accidentally found out is that the LLMs were well trained on all the patterns we knew. You know, maybe me, I use Enterprise Java a lot, Jakarta, Microprofile, JBoss, Quarkus, and LLMs they know whatever is inside a spec. So, and I tested a Vue LLM, so it looks everywhere looks great. And what I'm doing is I'm grounding the LLMs against the API, which is even better, because you can say, okay, you are only allowed to generate JAX or S code, and this is very easy to verify, because what is not in the namespace Jakarta RS, whatever, it is not the API, so it's simple. And then almost no hallucination. So in fact, there was never a hallucination, because it is like, it is so well described and specified, and there are no variations, so there is basically no hallucinations. And now it comes with a very short prompts. You can have a high output. So the semantic, meaning of Java prompts is great. And this is what is maybe overseen. So actually, how great LLMs understand Java, and how good code you can generate with LLMs in enterprise Java projects. So this is actually, like, we can also talk about that. And Goose is also great for that. But this is, you don't have to have too much steerings, no system prompts, they already know a lot of stuff, right? That's the interesting part.
That's right. The more that is self-documenting and things, the easier it is for the LLM. Yeah. But also there's another thing where, and maybe this is just anecdotal or something, but I think broadly a lot of people agree that LLM-generated code is far better if it's compiled code than interpreted code, because it runs it through a compiler, fixes itself based on everything, rather than actually waiting for,
and I also checked some research, and it seems like if the LLMs can derive the types from type-safe languages easier.
That's right.
Because they see the return value and parameters, and if it is not, otherwise it's really hard. And this is why you can have a far larger projects with Java, because if you do it correctly, you can pinpoint an LLM to a specific component, say, look at this and show me what's wrong there. But but we can talk about next time. So it was really interesting discussion. I had no idea what they are doing. Is actually that really small world after all these years.
It is. It absolutely is. And yeah, good to connect with you after a long time.
Yeah, 20 years, I guess, almost. Yeah, 20 years. I think 2006, 2007 was the Infinispan rewrite, right?
Yeah, I believe so, around then.
Yeah. Thank you, and see you next time.
Good. Thank you. And
where people can find you? Sorry, where people can find you on the internet? Forgot about that. So you have to know where are the open source projects and your social media, and I will also put it in the show notes.
I think the best place is Block's open source page. So opensource.block.xyz. That's our primary open source page. There's a link to our blog. From there, you'll find a link to our GitHub, to our Discord, and everything else. So I can try and rattle off the Discord URL, but that's
no, I would. Yeah, Block open source.
Primarily opensource.block.xyz.
Exactly, and AAIF.io. This is the Agentic AI Foundation from Linux. There we will find Goose agents and MCP. This is the home of these three specs. And block.xyz, right? This is the
block.xyz, yes. And the Agentic AI Foundation is growing as well. So, it's only those three so far, but expect to see a lot more in there. We're talking to a lot of people. There's some really cool projects that are hopefully very soon going to make their way into the foundation.
Perfect. Then see you next time.
Awesome. See ya. Bye-bye.
Bye.